We're interested in animal locomotion and would like to make robots to study animal locomotion. Because animal locomotion is a very interesting interplay between the body, the spinal cord and the environment. But to understand this interaction, we really need a body, and that's where the robot is a key tool. So we designed a salamander robot that very closely mimics the real motion of the real salamander. And it can both walk and swim exactly like the real salamander. It's a very old animal, it's an amphibian, and it's almost a living fossil of the first terrestrial vertebrates, so the ancestor of vertebrates like us, mammals. So by studying the salamander, we can study this key moment of evolution, the switch from swimming to walking, and especially how the spinal cord has reorganized itself to allow a new mode of locomotion. So the novelty of this work is really the approach we took to try to be as close as possible to the real physics of the body.
The species is called Chlorodelis. We looked at detailed X-ray recordings from the animal, so we could track the bones in 3D space, and that enabled us to create a very detailed model of the movements of the bones of the animal.
Neurobiologists have shown that if you electrically stimulate the spinal cord, at low level of stimulation this will induce a walking-like gait. If you stimulate a bit more, this gait accelerates, and at some point there's a threshold and it switches to swimming. So just changing the global drive that the brain sends to the spinal cord makes a complete switch between different modes of locomotion. So understanding this is very important, for instance, for neuroprosthetics. Being able to re-stimulate those circuits in humans in the long term is something very important, and for that you need to understand how the spinal cord works.